Hey, what's up? It's Jake from Nimbus DevOps, and we're going to go over Kubernetes clusters. So we built some stuff, and you're probably like, okay, cool, I built some things. I'm not exactly sure what all of this is, but I ran the commands and it worked, and that seems okay. So I want to go over what this is. So let me bring up a picture. So here is a picture of a cluster. Okay, and let me explain what this is. So Kubernetes coordinates a highly available cluster of computers that are connected to work as a single unit. The abstraction in Kubernetes allow you to deploy containerized apps to a cluster without tying them specifically to individual machines. So in the cloud, you have a lot of EC2 instances and stuff like that. Those are individual machines, and if you have a cluster of machines that you're using, you're still tying applications to individual machines. So to make use of this model of deployment, your apps have to be packaged in a way that decouples them from individual hosts. And you do that by containerizing them. So containerized apps are more flexible and available than past deployment models where apps were previously installed directly onto machines as packages deeply integrated with the host in that way. So the way Kubernetes does this is it automates the distribution and scheduling of application containers across a cluster in a more efficient way. Um, so let's take a look at how this works. So in this middle part, we've got two types of resources. We've got this control plane in the middle, and then we've got these nodes. Okay, so this is a node, this is a node, and this is a node. We have three nodes. The control plane, as we've discussed before, is responsible for managing the cluster. So it coordinates all the activities, scheduling, maintaining your desired state, scaling, rolling out updates, etc. The node is like a VM or a physical computer that serves as a worker machine in a Kubernetes cluster. Um, so that could be an EC2 instance, it could be a Raspberry Pi, it could be uh, a laptop, it could be anything. And each one of these nodes has a little kubelet. And it's hard to see, but this blue line here, this represents a kubelet. Um, and that's basically an agent, and it manages the node and communicates with the Kubernetes control plane. The node also has tools for handling container operations. So you'll want something on here like this light blue one. You probably can't read it. I don't know if I can zoom in at all to see this, but this is Docker. Um, so that would be the tool that we would use to handle container operations. It could be containerd, Docker, it could be whatever. The Kubernetes cluster that handles production traffic should have a minimum of 3 nodes because if one goes down, both an SED member and a control plane are lost and redundancy is compromised. And you can mitigate that risk by adding more control plane nodes. So when you deploy an app in Kubernetes, you tell the control plane to start the app containers, and the control plane schedules the containers to run on the cluster's nodes. And then those nodes communicate with the control plane using the Kubernetes API, which the control plane exposes. And end users can also use that Kubernetes API directly, which is what happens when you type kubecontrol. You're actually from your terminal communicating with the Kubernetes cluster via the Kubernetes API to the control plane. So the Kubernetes cluster can be deployed on physical or virtual machines. You'll see it runs on bare metal and it runs in the cloud. And I've been using minikube, so that's what we're going to use. It's just a lightweight Kubernetes implementation. It'll create a VM on my PC, and we can deploy a cluster using only one node, being my PC. The minikube it does work on Linux and Mac as well. And the minikube CLI will basically just give some really simple bootstrapping operations we can use to work with a cluster, like starting it, stopping it, getting a status, deleting it, etc. Um, so let's go check this out a little bit more hands-on. So what we want to do is we want to deploy a local development Kubernetes cluster using minikube. So first, make sure if you haven't already that you have minikube installed. Okay, and you can type minikube version or minikube status and just double check that you have that installed. Um, also, make sure you have Docker running so you can actually start minikube, uh, and then you should be good. So I have minikube started, and you can see that here. If I say minikube status, it says that it's running, right? So if I were to stop it, it'll go ahead and stop that. And then if that's probably where you're starting from right now, then all you would do is run minikube start, and that would go ahead and start that. And when I say that, I mean it'll start the cluster. So let's check this out. So if I type minikube start, we can see that I'm running on Windows 11. It's using the Docker driver. It starts the control plane. It pulls a base image. If it doesn't have the image locally, then it'll go get it. And then it'll restart that Docker container that I have if you already have one, and it'll go ahead and prepare Kubernetes on Docker, and then go ahead and get everything started. So now once you have this done, you're actually running a Kubernetes cluster. So we can use, instead of minikube, we can switch to using kubecontrol or kubectl, and we can use these commands now, and I can get the version. And here what we're seeing is, and this is how we're going to interact with Kubernetes from now on, by the way. So you can check if it's installed by just doing version, and it'll tell you if it's installed. So you can see both the version and the client of the client as well as the server. The version of the client, so you see client version right here. This is the version of like the actual tool, so like kubecontrol. Whereas the server is the version of Kubernetes that's running. Okay, and then there's some other details in there about the build as well. So now that we have access to this tool, let's check out our cluster and see if we can get some info. So I'm just running kubecontrol cluster info, and it says the Kubernetes control plane is running on my local host on this port, and core DNS is running at this address, and that's pretty much it. So we're pretty much good here. And if we have a cluster, then we should have a node, right? So let's run kubecontrol get nodes. And I can see I have one node. It's the minikube VM that was created. And that role is the control plane, and also what they consider the master, which I know probably needs to be renamed in today's society, but that's what it is. So there you go. We've got one node. And that's pretty much it. So if you're looking at creating a cluster with minikube, that's how you do it, and that's how it works. If you have any questions, let me know. And if not, then I'll see you in the next one.